So today we're going to be looking at Venn diagrams, but let's actually see what Venn diagrams are. Venn diagrams, basically what I'm saying is that there's two events, two things happening. I'm going to call one event A and the other one I'm going to call it B. So if you notice, let me highlight this oval. Notice how here I call it event A. So everything that is inside this oval, it happens with event A. So I'm saying the points 2, 3, 9, and 7. Right? Everything inside this oval, it's event A. Now let me highlight with blue this other oval right here. And this one, as you notice, I called it B. So everything inside the blue oval, and we tend to be a circle usually, everything inside the blue is event B. So the point 7 and the point 1. Now, interesting, point 7, you guys see the point 7? It's a point. I'm not saying 0.7. It's not a value. It's a label. It's a point, number 7. This point, the interesting part of this point is it is inside A and it is also inside B. So point the 7, it happens in A and it happens in B. Now, another point, let me just pick a random point, 2. This one is inside event A, but not inside event B. And obviously, you guys see the points 4, 6, 10, 8, and 5. Those are outside of the points A and B, outside of the events A and B. Okay, so we can see this Venn diagram, which describes the sample space of particular experiment, and we're going to call this events A and B. Okay, so now that we see what happens with Venn diagram, let me leave the labels in red and blue. So we see A, we see events B, and obviously everything outside is not in either one. We see that it says, suppose that sample points are equally likely. So all the points have the same probability of being chosen. So I'm going to see how many points are there in total. And I count them. Let me see in black. I'm going to see how many points are there. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I'm going to say each point has 0.1 chances of happening. Why 0.1? Because 0.1 times 10, because there are 10 of them, this thing is equal to 1. Remember, we talked about probabilities at the beginning of this unit, and I said probabilities is a decimal. It's a decimal number between 0 and 1. However, when I add all the probabilities, it should add up to exactly 1. Okay, so now here it says, suppose the sample points are equally likely, round to 2 decimal places as needed. Okay, so I'm going to round it to 2 decimal places if needed. Probability of A. Now, probability of A is basically all the points inside of A. When I look at this, I'm looking at what's the probability that I get the point 2 plus what's the probability that I get the point 3 plus what's the probability that I get the point 9 and what's the probability that I get the point 7. I'm looking at all the points inside event A. But we said that each of these points has a 0.1 probability of happening. 0.1 plus 0.1 plus 0.1 plus 0.1. When I add all of these, I'm going to get 0.4. Okay, that's not that hard. How about the next question? What's the probability that B happens? Well, if I look at probability B, I'm looking at the blue oval. I'm asking what's the probability that I get the point 7 plus that's the probability that I get the point 1. But I said earlier, each point has a zero point 0.1 probability of being chosen. So zero point 0.1 plus zero point 0.1. I want to say probability of B is 0.2. Now, some of you might say, wait up, Mr. Leonzo. If I add probability of A plus probability of B, 0.4 plus 0.2, that's not equal to 1. And you said that all the probabilities have to add up to 1. Well, I will say there's a couple mistakes on that. Probability of A plus probability of B not equal to 1. Two reasons. One mistake, we counted the point 0.7 twice because in probability of A, probability of B is there. One mistake we would have done. And then I will say mainly the main reason why it does not equal to 1 because there are points outside of A and B. Look at the points 4, 6, 10, 8, and 5. That's why probability of A plus probability of B does not all equal to 1. Okay, now let's see here. Suppose probability of 3 is equal to probability of 4, which is equal to probability of 6, probability of 8, probability of 9, and they're all equal to 1 over 20. Okay, first of all, let me change this. I don't want to deal with fractions. So 1 over 20 is the same thing as 1 divided by 20. So I'm going to say each of these points is 0.05. I'm going to change this to decimals. But then it says the probability of 1 is equal to probability of 2. It's equal to probability of 5, 7, and 10. And all these probabilities are equal to 3 over 20. Using my calculator, 3 divided by 20 is 0.15. Now, round to 2 decimal places as needed. What's the probability of A happening? Okay, so let me zoom out to look at my picture. I'm looking at everything inside of point A or circle A, oval A, or however you guys want to call it. So I'm looking at what's the probability that I get a 2 plus what's the probability that I get a 3 plus what's the probability that I choose 0.9 plus what's the probability that I get 0.7. So notice I saw each point inside of circle A or oval A. Now I know each of these probabilities, let me zoom in, have a different uh, percentage or different decimal. Probability of 2, I know is 0.15. How do I know? It's right here. Probability of 3, I know is 0.05. Probability of 9, I know is 0.05. And probability of 7 happening is 0.15. Now, add everything. Add the 4 decimal places there, add the 4 decimal numbers. So I end up getting 0.40. Okay. Now let's take a look at the other one. What's the probability of B happening? Okay. So first of all, I zoom out so I can see my picture. And I look at figure B. And I'm asking myself, okay, which points are inside of B? And I have the point 7 and 1. So I'm asking here, what's the probability that I get 0.7 plus what's the probability that I get 0.1? Again, I'm looking at the points inside oval B. Let me figure the percentage of each of these. Probability of 7 is 0.15. Probability of 1 is 0.15. When I add this, I get 0.30. Nice. Okay. Let's take a look at the next question. Consider the experiment depicted by the Venn diagram with the sample space S containing 5 sample points. Okay, so there's 5 points in here. The sample points are assigned the probabilities. Now, here, I don't see which values there are. So for this example, let's say they are all equally likely. Equally likely. There's 5 points, right? There's point 1, point 2, point 3, point 4, and point 5. Again, each of those will be given a value. If I'm not given a value, I'm going to say they're all equally likely. So that means they all have the same probability. So I'm going to call each of these 0.2. Remember, when I add all of them, it should equal to 1. So in reality, I just did 1 divided by 5 because there's 5 points. Okay. So what's the probability of A happening? So let me look at oval A. Let me do this in red. What's inside A? Well, the points E1, E2, and E3. So I'm asking here, what's the probability of E1 plus what's the probability of E2 plus what's the probability of E3? So now homework, I will give you the percentages, how much each of them are. But on our notes, I forgot to give you the percentages. So I gave you right now the 0.2 each of them. Okay, so E1 plus E2 plus E3. Basically, I'm asking what's 0.2 plus 0.2 plus 0.2. That gives me 0.6. Okay, now what's the probability of B? Let me do in blue. I'm gonna circle all of B. I'm looking at all the points inside of B. So I'm asking what's the probability of E2 plus what's the probability of E3 plus what's the probability of E5. Those are the 3 points that I see inside B. I know each of them are 0.2. Again, for your homework, I will give you different values of each of these points. 0.2 plus 0.2 plus 0.2 gives me 0.6. Now here, what's the probability of A intercept B? Interesting. Okay. Now, a couple things. There's a couple symbols. We're going to look at the U symbol, which is union, and this is intersection. It looks like an N symbol. Now, the U symbol is union. Basically, that means that everything is inside all of them. So if I say A union B, I'm gonna consider the points that are in A, in B, and in that they share, right? So A union B, for example, I'll be looking at the points E1, E2, E3, and E5. So union, it has to be in A, has to be of B. As long as it's inside one of the two circles, that's enough. Now, intersection, if I look at A intersection B, I'm looking at the points that are in A, but are also in B. So this intersection, this U upside down is basically I'm looking at the points that are inside of A, but are also inside of B. So I'm looking at the points that are inside both. So here I'm looking at what's the probability of E2 plus the probability of E3. Again, I'm looking at the points that are in A, but are also in B. So I'm looking at the points that have to be inside both. Okay, why did you not choose E1, Mr. Leonzo? Because it's not inside B. Well, why did you not choose E5? Because it's not inside of A. Okay, so I know E2 is 0.2 and E3 is 0.2, but when I add them, is 0.4.